Welcome, my dear students. We are going to study phase rule. Willard Gibbs in 1876 stated a general principle called phase rule. It governs the behavior of heterogeneous system. It is also possible to study the effect of temperature, pressure and concentration with the help of a diagram, which is drawn by the application of phase rule. Effect of pressure, temperature, composition on a heterogeneous system is studied. The Gibbs phase rule stated as it provided the equilibrium between any number of phases of a heterogeneous system is not affected by gravity or electrical or magnetic forces, but is influenced by the temperature, pressure and concentration terms only. Then the numbers of degrees of freedom F of the system is related to the number of components C and the number of phases P by the mathematical expression called phase rule. P plus F is equal to C plus 2. P capital P, then F is a capital, then C is a capital. Means P plus F is equal to C plus 2. The terms involved in the above relation. The first, that is the phase P. The word phase is derived from the Greek word meaning appearance. Any homogeneous part of the system is called a phase. A heterogeneous system consists of two or more parts and each part is homogeneous in itself. Each part can be separated from other parts. A phase is a homogeneous, physically distinct and mechanically separable part of the heterogeneous system. To be physically distinct, a phase should have a definite boundary, that is a bonding surface. The term mechanically separable means each phase can be separated from every other phase by filtration, decantation, hand picking of crystals by shape and color, separation of two liquids, immiscible liquids, phases using a separating funnel, etc. This doesn't include a fractional distillation, adsorption or solvent extraction. Then other term, that is the in form, that is the number of phases P. It is the number of physically distinct states present in a system at equilibrium. It is number of physically distinct states present in a system at equilibrium. For a gaseous system, gases are miscible in each other in all proportions, so the mixture of two or more gases constitutes one phase system because there is no bonding surface between the different gases or vapors. For a liquid system, a mixture of two or more completely miscible liquids is a one phase, that is single phase system. For example, water and alcohol. A mixture of two or more immiscible liquids form as many phases as the number of liquids present in the system. For example, water and carbon tetrachloride form a two-phase system. Water, benzene, mercury form a three-phase system. The system in which ice, water and vapor are equilibrium forms a three-phase system. A liquid in equilibrium with its vapor will form two phases. A liquid is in contact with vapor or other gases forms two phases. C6H6 plus H2O means benzene and water. It is immiscible two phases. Water and oil mixture. These are three phases: water, oil and the vapor of the water. Then for solid system, every solid constitutes a single phase. Heterogeneous mixture of solid substances also consists of as many phases as the number of solids. When solid calcium carbonate is heated in a closed vessel, three phases exist in the system at equilibrium. There are two solid phases, calcium oxide and calcium carbonate, and one gaseous phase of carbon dioxide. In a common salt, that is solid, dissolves completely in a water or liquid forming a solution, then it is taken as one phase. But if the same solid form a saturated solution with the liquid and some solid remains undissolved, then the system is of two phases, one of saturated solution and other of unsaturated solid. Then the dissociation of ammonium chloride is represented as ammonium chloride is dissociated into ammonia and HCl. Ammonium chloride it is in solid state and ammonia and HCl it is in a gaseous state. At equilibrium there are only two phases. Ammonium chloride forms solid phase, ammonia and HCl are in the form of a gas and they form one phase. Every solid constitutes one separate phase, but solid solution containing any number of solids, for example, mixed crystals of isomorphous salts, ferrous ammonium sulfate, is regarded as one phase because it is a homogeneous mixture. Each polymorphic form and allotropic form modification constitute a separate phase. For the gaseous phase, if you consider the ammonium chloride gives ammonia and HCl, XNH3 and plus XHCl equal amounts, then there is a one component system. When there is a arbitrary amount, the gaseous phase, the XNH3 plus YHCl, then number of components are the two. Then a number of components is the another term. It is a minimum or the smallest number of independently variable constituent by means of which the composition of each phase can be expressed in terms of the equation. The term component doesn't mean constituent while expressing the composition of each phase. Zero and negative values of components are permitted. One component system, the water system, is an example of one component system. Equilibrium between the different phases of water, solid water that is ice is equilibrium with liquid water, solid water is equilibrium with the water vapor, the liquid water is equilibrium with the water vapor. The solid water ice is a one phase, then it is equilibrium with the liquid water, it is a second phase, and the water vapor equilibrium, then there is a phase third. Then S2O, it is in a solid phase, is equilibrium with the S2O in a liquid phase, then the equilibrium with S2 in a vapor phase. The water system consists of three phases. Each phase can be expressed or represented by one chemical constituent, that is S2O. Hence, water system is a one component system. Then two component system. The calcium carbonate is decomposed in a closed container. The decomposition of calcium carbonate is heating to produce calcium oxide solid and the carbon dioxide gas. That is, calcium carbonate solid is heated to give a calcium oxide solid plus carbon dioxide gases. Here there are two solids and one gas. Here three phases coexist and it appears as if there as three chemical constituents. The composition of all three phases can be expressed in terms of only two of the three chemical constituents in equilibrium. The chemical constituents calcium oxide and carbon dioxide, calcium oxide and calcium oxide, then calcium carbonate and carbon dioxide. By selecting the calcium oxide and carbon dioxide constituents, by selecting calcium carbonate and calcium oxide constituents, by selecting calcium carbonate and carbon dioxide constituent, the minimum two constituents are required to express the composition of each phase, and hence the above system is the two component system. The dissociation of ammonium chloride produces NH3 and HCl. The ammonium chloride is heated in a closed vessel or the vacuum, and it exists in equilibrium with the products of dissociation, ammonia and hydrogen chloride gas. The system consists of two physically nameless solid ammonium chloride and the gaseous mixture containing ammonia and HCl. Moreover, in a gaseous phase, NH3 and HCl are present in the same proportion as in NH4Cl. It is a homogeneous mixture of gases. So the composition of both the phases can be represented by chemical formula NH4Cl. Then consider a system containing sodium sulfate and water. The various phases that may be occur are sodium sulfate, Na2SO4, then Na2SO4 7H2O, then Na2SO4 10H2O. Solutions: Na2SO4 in water, ice water or the water vapor. The composition of each phase can be expressed in terms of Na2SO4 and H2O. The composition of some phases can be expressed in terms of one constituent, either H2O or Na2SO4, but in other cases two independent constituents, for example Na2SO4 and H2O, both are required, but two components is the smallest number by which the composition of all the phases can be defined. Hence it is a two component system. Then number of degrees of freedom F. A system in equilibrium is affected by a factor like pressure, temperature and concentration, etc. The number of degrees of freedom, it is defined as the minimum number of independently variable factors such as pressure, temperature and concentration, which must be specified in order to define the system completely at equilibrium. The minimum number of intensive variables with the help of which the system can be completely defined are called degrees of freedom. A system with 1 degree of freedom is called univariant or monovariant system. With the 2 degrees of freedom is called as a bivariant system, and with no degrees of freedom then it is called as non-variant or invariant system. Consider the following examples. Consider the one component system. System consisting of pure nitrogen gas in a cylinder fitted with the movable piston by phase rule P plus F is equal to C plus 2. Here the P phase is 1, then substituting this formula component 1, then 1 plus F is equal to 1 plus 2, then F is equal to 2. The system has a 2 degrees of freedom and can be specified by two variables, pressure and temperature. Hence it is a bivariant system, means F is equal to 2. Then another example, consider one component system having two phases which are in equilibrium of a type water equilibrium with vapor. By applying the phase rule, P plus F is equal to C plus 2, then phases 2, one component system, then 2 plus F is equal to 1 plus 2, then F is equal to 1. Thus, this system has only 1 degree of freedom and can be specified by only one variable, temperature. Hence, the vapor pressure of liquid has a fixed value at a given temperature. Hence, it is a univariant system. F is equal to 1. Consider a system consists of a saturated salt solution in contact with a solid salt and vapor, like NaCl solid is equilibrium with NaCl solution is equilibrium with the water vapor. By applying the phase rule, P plus F is equal to C plus 2. The NaCl plus H2O, then C is equal to 2. Then C is equal to means component degrees of freedom F calculated. The P is equal to 3, C is equal to 2, P is equal to 3, substitute there, C is equal to substitute there, 3 plus F is equal to 2 plus 2, then F is equal to 1. This system has only 1 degree of freedom and can be specified by only one variable, that is the temperature. Because the solubility of salt and vapor pressure have definite values at a certain temperature, hence it is a univariant system. Another example, that is a consider one component system. The three phases are in equilibrium of the type ice is equilibrium with water is equilibrium with vapor. Then by applying the phase rule, P plus F is equal to C plus 2. The P is equal to 3, then C is equal to 1. Then 3 plus F is equal to 1 plus 3. 2. Then this system is a non-variant. F is equal to 0. It is exists only at a particular values of low pressure of 4.58 mm of mercury at a low temperature of 273.0075 Kelvin. Here there is a water is a one component system. It has three phases. P plus F is equal to C plus 2. Then P is equal to 3. C is equal to 1. Then 3 plus F is equal to 1 plus 2. Means 3 cancel. Then F is equal to 0. Thank you.